Have you ever stopped to think about what keeps us safe from the incredibly powerful machines that mix, grind, and package our food? Well, I can tell you it's not just luck. It's actually a complex, invisible shield built from rules and some really meticulous engineering. So today, we're going to pull back that curtain and look at the hidden world of machine safety design.
So, you look at this chart and you might just see a bunch of lines and numbers, right? But what you're really looking at is a safety blueprint. Its entire purpose is simple: to keep your fingers attached to your hand. It's built around the human body, and it dictates exactly how big an opening can be and how close it can get to a dangerous moving part. This isn't guesswork at all. It's a science, and it's designed to protect people right down to the millimeter.
Now, before engineers can even start to build that protective shield, they first have to map out the battlefield. And that means identifying every single potential threat, every possible way a machine could cause harm. In their world, they call these danger zones. So what exactly are they on the lookout for? Well, just imagine a massive industrial mixer. You've got trapping points where a limb could get pulled in. You've got shearing risks where parts slide past each other just like a giant pair of scissors. You have powerful rotating tools, exposed drive mechanisms, and of course, crushing hazards from super heavy components. And every single one of these needs its own specific solution. And believe me, the dangers go way beyond just the moving parts. A really solid safety design has to account for, well, everything. The risk of electric shock, especially when you're using water for cleaning. Burns from a jacketed mixing bowl that's used for heating things up. And even long-term hearing damage from just excessive noise. It's a full 360-degree view of risk. Okay, so the very first and, most fundamental layer of protection is often the simplest one, just a physical barrier. The whole idea is to put a solid object between the person and the hazard. But just because it's simple doesn't mean it's not sophisticated. Now, this is where the logic gets really fascinating, because it's all based on our own anatomy. Think about it. If an opening is just big enough for a fingertip, the standard says, okay, it can be pretty close to the hazard. But if that opening is large enough for your entire arm to fit through, that guard has to be placed way farther away. We're talking over half a meter. It just brilliantly shows how these safety standards are directly tied to the dimensions of the human body. These barriers, they basically come in two main flavors. You've got your fixed guards. These are for parts of the machine you almost never need to get to, like the main drive motor. They're bolted down tight, and you literally need a tool to get them off. Then you have movable guards. These are for your everyday access, like a lid you'd open to add ingredients. They're on hinges or slides, and they're way more dynamic. And when we talk about precision, it is absolutely non-negotiable. These standards, they spell out the exact dimensions. For an opening used to add ingredients, the rules are incredibly specific. The maximum diameter is 52 millimeters, not 53, not 55, 52. That single millimeter is the line drawn in the sand between safe and unsafe.
Right, so a fixed barrier works great, but what about that movable guard? What happens when an operator actually needs to open it to do their job? Well, this is where the next layer of protection comes into play.
And this is where the shield gets smart. We're moving from just a passive barrier to an active intelligence system. This is where the machine itself starts to think, reacting instantly to protect the user. The key piece of tech here is the interlocking guard. The concept is just brilliantly simple. The guard is electronically wired into the machine's brain. So if that guard isn't fully closed, the machine just will not run. It's impossible. The power circuit is physically broken. The sequence of events is just beautiful in its simplicity and its speed. The very moment an operator opens that guard, a switch gets triggered. That tiny signal instantly tells the control system to cut all power to the dangerous parts. And just like that, the massive, powerful mixing arm grinds to a complete and total stop. So how fast is instantly? Well, the standards are crystal clear on this. When that guard opens, any dangerous motion has to stop in less than 2 seconds. That's it. That's the maximum time allowed for a machine to go from full churning power to completely and totally safe. So up to now, we've been focused on protecting the worker from the machine. But in food processing, there is a second, absolutely crucial mission: protecting the food from the machine. And this brings us to the hygiene shield. Designers start this whole process by dividing the machine into different zones. So first, you have the food area, which is pretty much any surface the food is supposed to touch. Then you have the splash area, which is where food might splash, but it's not going to get back into the main batch.
And each of these zones has its own very strict set of design rules, all to prevent contamination.
Now, a primary enemy in hygienic design is something called dead space. This is any tiny little crack, corner, or seam where food particles, or worse, bacteria, can get trapped and hide from the cleaning process. So for any engineer designing food equipment, eliminating dead space is priority number one. So, designing for hygiene really comes down to a clear set of principles. Surfaces, they have to be perfectly smooth. Internal corners have to be rounded, never sharp. The materials have to resist corrosion from both food and all those cleaning chemicals. And the entire machine has to be designed so water can drain away completely, leaving absolutely nowhere for bacteria to set up shop. We've gone through physical barriers, intelligent systems, and hygienic design. But all of this sophisticated engineering, it all depends on one final critical layer: the people who actually operate the machines. This quote, it comes directly from a real machine safety manual. It's a simple, blunt command, and it just perfectly highlights the operator's fundamental responsibility. You can design the most advanced, foolproof safety system in the world, but it can always be defeated. And this really gets to the heart of the matter. Safety isn't just about the machine. It's a partnership. A perfectly designed machine and a well-trained, responsible operator have to work together to create a truly safe environment. One simply cannot function without the other. So when you think about it, these incredibly detailed standards, governing everything from the size of a tiny gap to the smoothness of a steel surface, they build an invisible shield that protects us every single day. And it kind of makes you wonder, right? What other hidden rulebooks, what other invisible shields are out there quietly shaping our world?